morning, students. Warmly welcome to Adarsh Educational Institution. It's my pleasure to welcome you all to the online class. In our last class, we discussed the topic of unit number 2, motion. So, rest topic for rest and motion, types of motion, distance and displacement, and speed, velocity, and acceleration. We discussed in our last class. So today, we discuss some problems in a speed topic and then graphical representation of motion along a straight line. These are the topic for today discussions. So first one, problem. The problem number one, an object traveled 16 meter in 4 seconds and then another 16 minutes in 2 seconds. What is the average speed of an object? What is the speed of an object? So to find out the average speed of an object. So first one, given solutions. So the distance traveled by an object. So 16 meter and 16 meters. So totally the object traveled in 32 meters. Time taken for 4 seconds plus 2 seconds is equal to 6 seconds. So total seconds 6 seconds and distance is equal to 32 meters. So to find out the average speed. So the average speed formula. What is the formula for speed? Distance traveled by time. Distance traveled by time taken. So total distance traveled by time taken. So 32 meters divided by 6 seconds. So if you divide this 32 by 6, it gives 5.33 meter per second. So you find out the average speed of the object. And then second one, problem number 2. A sound is here 5 seconds later than the lightning is seen in the sky on a rainy day. Find the distance of location of lightning given the speed of sound. So if you already give the speed of sound in that is 346 meter per second. So if you find the distance, that means the location of lightning. So what is the formula? Speed is equal to distance by time taken. So if you find the distance, so that's why distance is equal to speed into time. So speed of light, the speed of sound, that means the speed of sound is equal to 346 meter per second into time taken 5 seconds. So speed is equal to distance by time. So if you find that distance is equal to speed into time, so they given the speed of sound. So 346 into 5 seconds. So totally 1730 meter. 1730 meter. So the distance of location of lightning is 1730 meters. So next one, graphical representation of a motion along a straight line. So along a straight line, it contains a uniform and non-uniform motions are there. So first, if you discuss the distance and time graph for uniform motion. So they given a table. For example, plotting the distance and displacement or speed and velocity on a graph help us to understand certain things about the time and positions. Consider if you see the table, we show the distance walked by a person at a different times. So for example, if you take a time for 0, 5, 10, 15, 20 and then 25, it takes for distance for it covered 0 and starting point, that means 0 to 0, and it 5 minutes it will reach the 500 meters, and 10 minutes if you reach the 1000 meter, that means 1 kilometer, and then 15 minutes it covered 1500 meters, and then 20 minutes it covers 2000 meters, that means 2 kilometer, and then 25 minutes it covers 2500. So a graph is drawn by a taking the time along x-axis and distance along y-axis. The graph is shown. This graph is shown. So the x-axis is taken as a time, and then y-axis is taken as a distance. So the graph is known as distance time graph. So just if the value it will be plotted the graph. So 5 seconds and 500 meters, and 10 seconds 10,000 meters, 1000 meter, and then 15 minutes 1500, and then 20 2000, and 25 2500. So the x-axis it contains 1 centimeter is equal to 5 minutes, and then y-axis 1 centimeter is equal to 500 meters. When we look at the distance time graph, we notice a few things. First, it is a straight line. We also notice that the person covers equal distance in equal interval of time. So that's why this one is a uniform motion. We can therefore conclude that he walked at the constant speed. Can you find the speed at which walked from the graph? The parameter is referred as the slope of the line. That means the slope. If you find out the slope, that means for if you find a, b, c, and then so if we find draw that slope onto speed is equal to formula for speed in average speed. If you calculate the average speed, so that's why speed is equal to distance covered by time taken. The slope of a straight line, that means a bc and then ac, bc divided by ac. So bc, it covers how many meters? 500 meters. And then ac, it contains 5 minutes. So 500 divided by 5 is equal to 100 minutes per 100 meters per minute. So 100 meter per minutes. So that's why. So let us take a look at the distance time graph for a three different peoples. Asher's walking, Safira cycling, and then Kanishka going in a car. So along a same path, we know that cycling can be faster than walking, and a car can go faster than a cycle. So the distance time graph of the three would be given in the following graph. The slope of a line is distance time graph becomes steeper and steeper as speed increases. So if you comparison the graph, so when a car is riding distance, it will be covered in a few minutes, and then cycling it have taken in a more minutes. The walking it contains it has more minutes. So and the next one, distance time graph for non-uniform motion. We can also plot the distance time graph for accelerated motion. That means the non-uniform motions. They show the distance traveled by a car time interval for 2 seconds. So if you see the table, so it contains a table. So 0 for 0 distance, 0 seconds, it will, that means the starting point. So it contains 0 seconds, it contains 0 meter, and 2 seconds it covered 1 meter, and 4 seconds it covered 4 meters, and 6 seconds it covers 9 meters, and 8 16 meters, and the 9 10 seconds 25 meters, and 12 seconds 36 meters. If we plot a graph between distance traveled and the time taken would be shown in the figure. You see the figure. The distance time graph for a non-uniform motion. Note that the graph is not a straight line as we got in a case of uniform motion. This nature of the graph shown in non-linear variations of the distance traveled by a car with time. The graph represents motion with non-uniform speed. And next one, velocity time graph. The variation of velocity of an object with time can be represented by velocity time graph. In the graph, time is represented along the x-axis and the velocity is represented along the y-axis. If the object moves at a uniform velocity, a straight line parallel to x-axis is obtained. This graph shows the velocity time graph for a car moving with uniform velocity of 40 km per hour. We know that the product of velocity and time gives displacement of an object moving with uniform velocity. The area under the velocity time graph is equal to the magnitude of the displacement. So the distance, that means the displacement, is covered by the car in a time interval of time, that means can be expressed as what is it, a b c d. So speed is equal to ac and then into cd, ac into cd. So s is equal to area of the rectangle, that means a b c d, shaded area. So we can also study about uniform acceleration motion by plotting its velocity time graph. Consider a car being driven along a straight road its velocity for every 5 seconds is noted from the speedometer of the car. The velocity of the car in meter per seconds at different instant of time is shown in the table. That means it's shown in the figure. It's shown in the table. That means time and then velocity of car. And 0 second it contains 0 meter per seconds, and 5 seconds it contains velocity 9, and then 10 the velocity of car is 18, and then 15 is velocity 27. So on 20 seconds velocity of 36 meter per seconds, and then seconds 25 seconds and 45 meter per seconds, and then 30 seconds it contains velocity of car 54 meter per second. In this case, the velocity time graph for the motion of a car, the nature of the graph shows that the velocity changes by equal amount in equal interval of time. All uniform acceleration motion, the velocity time graph is straight line. One can also determine the distance moved by the car from this velocity time graph. The area under the velocity time graph gives the distance, that means magnitude of displacement moved by car in given interval of time. Since the magnitude of the velocity of car is changing due to acceleration, the distance, that means s traveled by a car, will be given by the area of a, b, c, d, e. So a, b is under the velocity time graph, that is s is equal to area, that means a, b, c, d, e. So that means area of the rectangle a, b, c, d, and area of a triangle a, d, e. So area of a rectangle and then area of a, that means AB. So ABCD is a rectangle, and then triangle, area of a triangle ADE, and the area of a quadrangle ABCDE has been calculated by calculating the area of trapezium. This is the trapeziums. This one is the trapeziums. ABCDE, area of the trapeziums. It means the area of a trapezium ABCDE is equal to half into sum of the length of parallel sides into distance between parallel sides. So half into AB plus AB plus, that means AB plus AB plus CE into BC. So in this case, non-uniform acceleration motion distance time graph and velocity time graph can have any shape as shown in the figure. If you see this figures, this is the velocity time graph for non-uniform accelerations. So then already if I told the velocity, to calculate velocity of car, if we find out to calculate the speedometer of the car. The speedometer of an automobile measures the instantaneous speed of the automobile in uniform motion in one dimension. That means the average velocity is equal to instantaneous velocity. Instantaneous velocity is also called velocity or instantaneous speed or simply speed. So thank you students. Don't skip the videos. Thanks for watching.